Hello everyone, welcome to week 4 of physical science. We're going to take what we learned last week about forces and apply the force to cause a change in speed, to cause some motion. So, specifically, calculating speed. Let's get started. So, for speed, it is a measure of the distance an object travels per unit of time. So, how far you go and how long it takes you to go that far. So, we have in a calculation a formula. Speed equals distance over time. Let's try it out. So some practice problems. So in this first picture here, this car went 20 meters in 2 seconds. M is meters, S is seconds. So 20 meters in 2 seconds. We have our distance, 20 meters, time, 2 seconds. So 20 meters divided by 2 seconds. 20 divided by 2. We probably don't need a calculator for this, but let's try it out anyways. 10! What a surprise. So that's 10, but we can't just say 10, because if speed is 10, that can mean a couple of different things. 10 miles per hour, 10 meters per second, 10 kilometers per hour. We take our units from the units given to us. So if we start in meters and seconds, our unit is going to be meters per second. So units are really easy. We don't have to think of any new units. It's just whatever is given to us, meters and seconds. But let's look at another example. Say we only went 10 meters in 2 seconds. So again, 10 meters divided by 2 seconds, distance divided by time. 10 divided by 2. Again, we probably don't need a calculator, but who knows, math might change. 5. So you end up with 5, and again, we need units. What do you think our units are? Meters per second again, because again, given meters and seconds, meters per second. So that's kind of the gist of what we're learning today, but there's a couple other terms, a couple other words that I want you guys to know. One is average speed. That is the total distance traveled divided by the total time. So just like the average of anything, you take all of the information and divide it. And then we have instantaneous speed, like instant speed. It is a speed at a specific instance in time. So average speed is the average speed over an entire car trip. Instantaneous is just at one particular moment. How fast are we going? So what is the average speed of a person who traveled a total of 3 miles in 1.5 hours? So 3 miles in 1.5 hours. First off, that is so slow. So 3 miles divided by 1.5, because we have distance divided by time. 3 divided by 1.5. We have 3 divided by 1.5. We get 2. So we have 2, and again, we need our units, and it's whatever is given to us. So we were given miles and hours, so our unit is miles per hour. And you might even write it mph. That's a pretty standard way to write miles per hour. So then, unit of speed, we've talked about this a little bit, so this is just a summary. So if you want to pause and read that, go for it. Otherwise, what is the unit for the following problem? Justin traveled 60 miles in 1 hour. So we were given miles and hour, so our unit is miles per hour or miles per hour. And then something very similar to speed is velocity. Most likely, if you've heard the word velocity before, you thought it's exactly the same as speed. And it almost is. The only difference is that it is a description of speed and direction. So looking at this picture, we have 1.5 meters per second to the left, 1.5 meters per second to the right. Velocity is extremely similar to speed, you just add a direction. So the two students in the picture, do they have the same velocity? No, they have the same speed, 1.5 meters per second, but different directions, so different velocities. So that's kind of just a little extra description that you can do. So know that speed and velocity are very similar, you just have to add direction. And then the last thing is acceleration. So when something accelerates, normally you'd think, like, if your car is accelerating, it's going faster. So acceleration is a change in speed or direction, but we mostly think of speed. So an example is speeding up or slowing down. Or if you change directions, you could also consider that to be acceleration, tying in the fact with velocity that it's all about direction. So we have a skateboarder here with different velocities or speeds in this case because he's going the same direction the whole time. And then we have a formula for acceleration, but you don't have to worry about that. You just have to worry about speed this time. So if you start by going 10 meters per second and end going 10 meters per second, did you accelerate? Nope. Your speed did not change, and I didn't tell you anything about direction, so you don't have to worry about it. This is just a sneak peek of Friday's lesson where we talk about the speed triangle. Dun dun dun. All right, so that is all we're going to talk about today. So that's all we're going to talk about today. Go ahead, finish up the rest of the speed web quest. So look at the websites, look at the videos, answer the questions, try the practice problems. If you have any questions, please let me know, and I hope you have a great day. Bye.